Let's use the definition of derivative to take the derivative of the square root function. Looking at this graphically, I'm just seeing the square root function looks like that. So I see really steep slopes to start with, getting smaller and smaller, but always positive. So I'm thinking that the derivative function should look something maybe like that, starting off really high positive because the slopes are really big positive, still staying positive slopes but getting less and less, right? So I'm thinking that's going to be the derivative, looks something like that. But let's see how it comes out. So f prime of x is by definition the limit as h goes to 0 of f of x plus h minus f of x all over h. I haven't actually done anything yet, right? That's just the definition. So let's apply that definition to our function now, or apply our function to that definition one way or the other. Well, the f of x right here is just the limit as h goes to 0. The f of x is just that square root of x, and I'm subtracting that. What is f of x plus h, right? Well, this is saying whatever you're doing with x, whatever you plug in for x, take its square root. So if you're plugging in x plus h, take its square root. So x plus h is all under the square root, and divide by h. Okay. If you try plugging in h equals 0 here, it looks like you got a square root of x plus 0 minus the square root of x on the top, and a 0 on the bottom. That's a 0 divided by 0. Okay, I've got some work to do. How are we going to do this? Factor and cancel doesn't quite cut it for us, but with radicals, we did this thing, remember, doing rationalizing. So I'm going to take the limit as h goes to 0. I've got a square root of x plus h minus the square root of x over h. I'm going to multiply by 1, right? And the form that I choose for that 1 is the conjugate of this thing. So take the same two radicals, x plus h and square root of x, and put a plus sign in between them. Okay. So I'm going to multiply the tops together here, and I'm going to multiply the bottom. The bottom I'm going to leave factored because I already can see that h is the h I'm trying to cancel out, right? That's the factor of 0 on the bottom. I'm just looking for a factor of h on the top. Let's see what happens here. Okay. Limit as h goes to 0. So the denominator I'm just leaving as h times this stuff, square root of x plus h plus the square root of x. The numerator I'm going to FOIL, so I've got to do firsts, I got to do outsides and insides and lasts, right, to FOIL that thing out. So the first is this square root times the same square root. That's just x plus h. The outsides are this square root times, square root of x plus h times the square root of x. And then the insides are the square root of x plus h times negative square root. So outsides and insides actually cancel out. That's why we multiplied by the conjugate, so they get rid of the outsides and insides. And then I have negative square root of x times the square root of x, which is just minus x. Right? I didn't just square top and bottom because I'm not allowed to do that. I would change the value. What I did was I multiplied by 1, and I chose the right form of 1 to make the top do something nice. Right? Now I can see I've got a plus x and a minus x. Those are going to go away. And what I have now is the limit as h goes to 0 of just an h on the top, and then h times this stuff on the bottom here. What's this? H times the square root of x plus h plus x, square root of x. There's my factor of h, top and bottom, all ready to be canceled out. So let's do it. Take that h, cancel it. Be careful. Sometimes people cancel it out and forget that this is still on the bottom, that there's a 1 up on the top, right? This is h times 1 on the top. So I'm now looking at, I've canceled out the 0 over 0, so let's plug that h equals 0 in. I've got a 1 on the top, I've got a square root of x plus 0, plus a square root of x. Notice where before that square root of x was minus the square root of x when it was like this, and that created a 0. Now with a plus sign in between, it doesn't create a 0. It's just the square root of x plus the square root of x. Well, that's 2 times the square root of x. So here we go. To recap, started with f of x equals the square root of x. F prime of x is 1 over 2 times the square root of x. Right? So this function here is telling you the slope of the tangent line at any point. Let's do it for instance here. Here's the graph y equals x squared. How about if I plug in x equals 4, right? What's the slope of the tangent line right there? Right? Well, it's not very steep. I can see certainly less than 1. What this is telling me, what this derivative is telling me, if I look at what is f prime of 4, it's 1 over 2 times the square root of 4, which is 1 over 4. But the slope right here is 1/4. At any point, you tell me the x value, I plug it in to the derivative function, and it tells me the slope of the tangent line right there. Right? The original function tells you the y value right here. The derivative tells you the slope of the tangent line right there. All right, well, there's the derivative of the square root function.